So we'll go on and get started with what we're looking at today. Now, a lot of what we're looking at today is just dealing with the properties of logarithms and these logarithmic functions. Markers out. And there's three main properties that we have with logarithms. The first one's the product property, then we have the quotient property, and the power product. So our product property states that if we have two things being multiplied inside of a logarithm, we can rewrite it as addition of those two logs. So if we have log of m times n, we can rewrite it as log of m plus log of n. Our quotient, make sure I spelled quotient right, states that if we have two things being divided inside of the logarithm, we can rewrite it as subtraction. And the last one is our power property. If we have something to an exponent inside the logarithm, we can move the exponent out front. And these three here are our basic product, or our logarithmic properties. And again, when we split them up, the base of whatever the logarithm will remain the same. We're not going to just change the base for these here. Now, there is a change of base property, which we will look at in a little bit. And this here is sometimes helpful for either splitting it up to solve it better or to put it back together. So we can go in one direction or the other. Now, the first one we're going to look at is these here, and using these properties to simplify these here. Now, they told us here that log base 2 of 3 is 1.585, and log base 2 of 7 is 2.807, and we want to evaluate these logs using these properties here. Now, looking at this first one here, we have log base 2 of 3 divided by 7. Now, according to our quotient property, whenever we have two things being divided inside the logarithm, we can rewrite this log as subtraction. So that means I can rewrite this as log base 2 of 3 minus what? Log base 2 of 7. Because whenever we have two things being divided inside of a logarithm, we can rewrite it as 2 logs being subtracted. Any questions on how we did this here? We good with this here so far? Now, to finish evaluating this, what did we say log base 2 of 3 is? 1.585 minus, well, log base 2 of 7 is told to us to be 2. Now we just need to subtract these. Negative 0.8. No. 2. 2. Is it negative 0.222? Negative 1.222. That's it. Now, for those of you who have taken the ACT class, we've seen ways that we can plug this in. And the main thing we're trying to do with this here is just to get used to these properties of addition and subtraction and multiplication and powers. That's what we're really trying to get at. So here, there are ways to using the graphing calculator to type in log base 2 of 21. But we want to use these different properties that we have with 3 and 7. Well, we do know that 21 is the same as saying 3 times 7, because 3 times 7 is 21. Now, whenever we have two things multiplied together inside of a logarithm, we can rewrite it as 2 logs being added together. So 3 times 7, log base 2 of 3 times 7 can be rewritten as log base 2 of 3 plus log base 2 of 7. Now we can use what they told us, that log base 2 of 3 is 1.585 plus 2.807. And this time we just need to add I believe it should be 4.392. And if you tried typing in the calculator, you do get something close to this, but it has a lot more decimal places. Because these here, for log base 2 of 3 and log base 2 of 7 are approximations. They're not the exact value. Questions on any of this here? We good with this here so far? Log base 2 of 49. Well, and again, with any of these here, we're really just rewriting them as 3 and 7. So I could rewrite 49 as what? 7 squared. Because 7 times 7 is our 49. Now, according to our power property, we can take this exponent and move it out front, which tells us that we have 2 times log base 2 of 7. Questions on this so far? Well, log base 2 of 7 is our 2.807. So we're just multiplying it by 2. Which would give us 0.614, I believe. And that would be it. Any questions on any of this here? We good with this here? Okay. Let's look at a few more of these here, and then we'll move on to the next part. So here we have log base 3 of 4/5. Well, we can rewrite this as log base 3 of what? 4 minus log base 3 of 5. Because whenever we have something being divided inside the log, we can rewrite it as subtraction. And now we can calculate this out, because log base 3 of 4 is 1.626 minus log base 3 of 5, which is 1.465. Now this one here would be negative 0.203. And that's all we have to do. So most of this is just utilizing this property and this together. Questions on any of this here? We ready for the next one? Log base 3 of 20. Since we're not typing it into the calculator and they only gave us one for 4 and one for 5, well, I could rewrite 20 as 4 times 5. And our product property states that we can rewrite these as the sum of 2 logs. So we could say the log base 3 of 4 plus the log base 3 of 5. Which would give us 1.262 plus 1.465. Point two, which I believe should give us 2.727. Any questions on this here? Not too bad. Well, I believe this is the last one of this type before we move on to the next part. I think we have 3 after this, but we'll look at this one here. Now, we can rewrite this as 5 squared, yes? And because of this, we can move the 2 to the front, telling us that we have 2 times log base 3 of 5. Well, log base 3 of 5 is 1.465. And if we multiply this together, we should get 2.930. Yeah. And that's it. You know, on those last two, I kept going from left to right instead of right to left. But questions on this here? What do we think of using these properties? They're not too bad. So if we feel comfortable with these here, we'll move on. By the way, on the assignment for this here, these are contained in the book. I think one of these or one of the previous ones that we use will show up on the homework. So you'll have to look back at this here. I think it's one of these two, because I think the homework will be dealing with log base 6. They'll give you 2. And if I remember correctly, for some reason, it's either this one or this one. One of these show up that you need for it. So it's just a page or two before in the chapter, okay? If you do get stumped on that and don't remember it, just ask. I can point that back out. But I think we feel comfortable with those there, yes? So we're going to skip those few and look at this one here. This one here is just wanting us to expand it. So we're using the product, quotient, and power rules to expand this all the way out. And when we look at this here, in the order that we're going to expand, the first thing we will use is quotient, our division property. Then we will use our product, our multiplication property, and last will be the power property. We're going to go in this order when we're expanding. So, looking at this here, and again, logs and natural logs have the same properties. They work the same way. So here we do have 2 things that are being divided, because we have the 5x to the 7 is being divided by y. So what we can do is we can rewrite this as the natural log of 5x to the 7th minus the natural log of y. And we know we're going to be done is when there's no exponents left and each log only has a single term. So looking back at this, do we have any more division left? Well, no. So we can move on to the next one, which is our product. Do we have anything being multiplied together? Well, yes, we have the 5 and x to the 7. Whenever we have 2 or things being multiplied together, we can rewrite them as addition. So what that'll tell us is that we have the natural log of 5 plus the natural log of x to the 7 minus the natural log of y. So after doing that, do we have anything else that's being multiplied together inside the log that's not an exponent? Well, no, we've got everything one term because we just have 5, we just have the x, we just have y. So that brings us to the last one. Do we have any powers? We have the 7. And according to our exponent property, we can move it to the front. which will tell us that we have ln of 5 plus 7 ln of x minus ln of y. Do we have anything being multiplied together inside the logs? Well, no. Do we have anything being divided? Well, no. Do we have any exponents? That there's the final answer. It's expanded all the way out. Any questions on any of this here? So, let's expand the natural log of 3x to the 5th divided by y. So what can we do first? The quotient, our division. So we can rewrite it as ln of 3x to the 5th ln of y. 3x to the 5th minus ln of y. What property are we going to use next? The product, our multiplication. Because we do have 3 times x to the 5th. Whenever we have more than one thing being multiplied, we'll deal with it next. So we can rewrite it as ln of 3 plus ln of x to the 5th minus ln of y. Now I will say, if we haven't had it yet, but the ln of y, if it was more than one term, when we split it up using this addition property, we'll need parentheses around it, because that negative is applied to everything in the denominator. So if we have more than one term in the bottom of the fraction, those will also have a negative in front of it. Now looking at this here, are we done? No, we still have the x to the 5th. We have to move the 5 out front, which will tell us that we have ln of 3 plus 5 ln of x minus ln of y. Now are we finished? Yes. And that right there is the final answer. Any questions on this here? Are you ready for the next one? Log base 6 of 3x to the 4th. Which property do we want to use first? So quotient would go first. Do we have anything being divided? No. So that's where we would start. We would start there, but since there's no division, we don't have to use it. We don't have anything to do there. So we can move on to the next one, which would be our product, because we do have 2 things being multiplied. So we can rewrite this as the 2 being added together. So log base 6 of 3 plus log base 6 of x to the 4th. Then what can we do next? Our product, or our power rule. We can move the 4 up front, which would give us log base 6 of 3 plus 4 times log base 6 of x. And that there would be the final answer. Questions on any of this here? Let's look at the next one. So, ln of 5 divided by 12x. So the first property we can use is our quotient, which would give us ln of 5 minus ln of 12x. Then our next property would be our product. Because we do have 2 things being multiplied together, we have the 12 and x. So we can say that we have ln of 5 minus ln of 12 plus ln of x, yes? No. Because again, since we split this up with that negative, we really need to consider both of those kind of in parentheses. Because that negative is attached to both. So really what we're looking at is ln of 5 minus ln of 12 minus ln of x. Any questions on this here? Is there anything else we can do with this here? Most likely I would say no, but I'm wanting to see how nitpicky they want to be. Okay, they're not going to be as nitpicky as I thought. And the reason I say that and kind of emphasize that is because 12 can be rewritten as what? 4 times 3. Well, or we can rewrite it as 2 times 2 times 3. So if we wanted to be really nitpicky, we could break the 12 up into its primes and continue going down from there. We're not going to. We can call this good. Any questions on this here? I'm just looking to see what we have. Okay. So do we feel comfortable with expanding these out? Yes? Now the next one we're going to go with is condensing. We're going the other way around. And normally we would go in the opposite order. Because if we expanded it, we went quotient, product, power. So if we're going the opposite direction, we would go what? Power, quotient. But then we get some of the cases where we have the negatives and the order in which the negatives go. How would we combine them? It can get a little confusing. And with a little bit of thought and focusing in on this, the order that we're going to do this is a hair different. We are going to do powers first. And then we're going to do product. And then we're just going to fix the powers. And these are the only two. I'm not going to focus on quotient because, again, what we're doing is we're going to put the quotient kind of mixed in with the powers. Now that sounds a little bit weird on how we're going to do that, but what I'm going to do is I'm going to treat any negative as a power. So if we look at this here, because we have log of 9, is there an exponent in front of log of 9? No, so according to the powers, it's going to stay the same. Because our power rule says if there's an exponent inside the log, it moves out front. Yes? If we go the other way around, if there's an exponent out front or a number out front, it's going to go back into the exponent. So our middle one, this 3, this positive 3, is going to go back to be an exponent. Since it's positive, we'll have plus log of 2 to the third. Now the next one we have is minus log of 3, yes? And negative, what is the number in front of log of 3? It's not written, it is a 1, yes? And the easiest way I found to deal with this is I'm going to treat this as an exponent. As our property is, I'm going to move that negative 1 up top. And since I move the negative, it becomes positive. Do we have any more of the quotient rule now for this here? No, because those subtractions are our quotient rule. So pulling it up as an exponent gets rid of that, leaving us with log of 3 to the negative 1. Now, the reason I say that this is nice is because if we had anything added after it or subtracted after it, it gets a little funky, especially if we're doing a division of a division of a division, breaking it down. Here, well, once we do the next step, anything that has a negative exponent goes from the numerator to the denominator. We take care of it. It's a lot easier to work with. So we finished the power rule, yes? The next one is product. Any logs that are added together can be rewritten as one where they're being multiplied together. So even though we have three of them all being added, we can rewrite it as the log of 9 times 2 to the third times 3 to the negative 1. Any questions on this here? Now, we're not actually going to find out what this value is. But if we wanted to, we could type this into the calculator. And when I say type this in, I just mean this part right here. Because just like with expanding, our final answer is still going to have log of something. We're not going to just have a number. Now, if we want to multiply these together, well, we'll need to simplify 2 to the third, because 2 to the third is 8. 2 times 2 is 4, times 2 is 8. Now, we'll also need to simplify the negative 1. To make it positive, we move it from the numerator to the denominator. And now we do need to simplify this here, because we do have 3 numbers, and we can simplify that. 9 divided by 3 is 3. 3 times 8 is, so we get log of, and I have a feeling if you type 9 times 2 to the third times 3 to the negative 1, it gave you 24. Yeah, so we could have typed that in and got the answer as log of 24. Questions on this here? Would you be ready for the next one? So looking at this here, the first thing I would do is our exponents. Now, since log of 6 is positive and there's not a number in front of it, nothing's going to change. So we have log of 6 plus, because I'm not going to mess with any addition signs, any positive signs. But the 4 is going to need to move to the exponent, giving us log of 3 to the 4th. Then what are we going to have next? Plus, because I'm going to treat this negative 1 as an exponent, plus log of 3 to the negative 1. If there is a number in front of that log with the negative, we'll take the negative and the number with it. So it had been negative 2 log of 3. We would rewrite it as plus log of 3 to the negative 2. Any questions on what we've done so far? Now we can rewrite it as a product of these being multiplied together because they are all being added of log of 6 times 3 to the 4 times 3 to the negative 1. Now there's different ways we can go from here. One of them is I can just plug 6 times 3 to the 4 times 3 to the negative 1 into a calculator, and it would give me an answer. But whenever we have like bases, they add the exponents, yes? So 3 to the 4th times 3 to the negative 1. 4 plus negative 1 is 3, yes? So we could do it that way, saying we have log of 6 times 3 to the 3rd, which would give us log of 6 times 27 to 182, 162. A little off. Yeah, because it would have been 4, not 6. We'd get this here. If we wanted to go the other way, we could have said log of 6 times 81 over 3, because we could have moved the 3 to the denominator. Well, no matter how we want to do this, if we wanted to do 81 divided by 3 would give us 27. Or I could do 6 divided by 3, which is 2 times 81, which is log of 162. Either way we do this, we still get to the same answer. Questions on any of this here? How do we feel about these here? Okay. We can go on and move on from this here because I feel especially with these numbers, they're not that bad. Would y'all agree with those there? Let's look at number 7 here just to see this, because we do have a variable thrown in. It's not that difficult. Here we only have 2 terms, yes? So we could deal with using the exponents and moving this up, which would be log of x plus log of 9 to the -1. Which our product property tells us that this would be log of x times 9 to the -1, which would be log of x divided by 9. Now for this one here, if we'd have used the division property, we would have actually gone straight to the answer. So this one here is one of the few times that using just the quotient rule actually would be faster. We just go from here to here. But either way, it still works. Any questions on this here? This is the last thing we have is the change of base formula. Change of base. States that log base b of x, I think they use something different, is equal to log of x over log of b. Now the reason we do this is because when we use this change of base, what we're changing the base to, I don't want to change it to 10. I want to change it to a base of 10 if we're using logs, because log base 10 is our common log. The button on Indy's standard calculator, this log is base 10. It makes it easier to calculate. Now, we don't have to use that. We could use it for any type of log with the same base, but we normally use it as base 10. Now, if we set the base as b, we're not using log, log anymore. It would just be ln. So this actually works out to be the same as ln of x over ln of b. It works out that the natural log for this change of base is the same as the log, interestingly enough. Questions on this change of base? So if we want to evaluate this using common logs, so log base 3 of 8, rewritten using the change of base would be log of 8 over log of 3. And that's it. So we put log of whatever the number is inside on top, and then we put log of the base on bottom. Y'all ready to see this written as natural logs? It's the same thing. Instead of log, it's ln. And we get this here. Questions on this so far? Now again, whenever we say evaluate, we're going to end up with a number, because that's pretty much the track record with this terminology here all the way up to this point, yes? So at this point here, we're going to plug it into a calculator. So we can say log of 8 over log of 3. because that's what we had, yes? And hit enter. And we get this not so nice looking decimal, yes? Well, let's say ln of 8 over ln of 3. We get the exact same thing. So these give us the exact same answer. So we'll go 4 decimal places over, so 1.8928, and that's our answer. Really, this whole thing is our answer, but we get this here. Questions on change of base? We kind of like change of base. Change of base is nice, especially if, like, what's inside the log was 10, because log of 10 is 1. So if this had been log base 3 of 10, we'd have log of 10 over log of 3, so it's 1 over log of 3, and we can figure out what that is. So sometimes it is helpful. All right. We'll look at 1 or 2 more of these, and then we'll move on, because I don't think we need to sit on this one for too long. How would I rewrite this one? Yes, log of 11 over log of 7. Or we could say ln over ln of, and if we type that in, we get 3, 2, 3. That's it. Questions over any of this here? I don't think we need to see another one of these, do we? Now, one of the things I will say, because this one here, log of 24 over log of 6, we have this here. And I've seen this before. Don't write this down. Please do not write this down. This is not the same as log of 24 over 6. These are not the same thing. Because our division of 2, this here is actually the same as what? Log of 24 minus log of 6. Did y'all see that distinction here? It is very common, I've seen it before, that we want to try to connect these two here. It just does not work out. Okay? So I just wanted to point that out, that those aren't the same. And the other one that comes up sometimes is log of 24 minus 6 is not the same as log of 24 over log of 6. Does that kind of make sense? And this here seems, well, that's obvious. We can do 24 minus 6. Well, when we start dealing with variables, that might be a tendency, but those don't work either. Kind of good so far. And I believe it's just more of the same. That's it. And that's all we're going to do here.